Today we have Prince online to talk about the SONiC HLD and the Yang. So, Prince, are you ready to go?
Yes, Krishna.
All right.
Sharing my screen.
Hmm?
All right. Okay, so let's get started. Today we will discuss about the HLD for SONiC Dash, basically bringing up SONiC on an appliance or a smart switch. So this is covering the overall scenarios and the schema definitions. Um, we will go over in detail on the HLD. So yeah, feel free to stop me anytime if you have questions. And I have to thank those who have contributed to the HLD. As you can see here, different folks have contributed to HLD. So I will probably reach to that section and ask them to explain on that. Okay, so on the requirements part, we have divided it into two phases. So first one is the VNet to VNet scenario and the route and LPM support underlay IPv4 and V6, stateful ACL, state tracking on flows, and telemetry and monitoring. We are not considering in this design, at least for now, the private link service tunnel and overlay IPv6. So that's on the requirement side. These are some details like on the device metadata and SWSs, how to bring up the device in an appliance or DPU mode. So typically, as most of you would know, the SONiC currently has different subtypes like Tor router, leaf router, which is all defined for the switch or networking devices. But since this is something new, we have come up with these um, conventions. Yeah. So any questions on the requirements? All right. So coming down to the CLI, so since most of the configurations to SONiC device configurations, etc., will be all driven by the controller, we're not planning to provide lots of config options to CLI. So mainly um, targeting for to support show and clear commands. So this is also some feedback we got from partner teams. So basically for the dash show commands and clear commands for some kind of debugging operations, that's the plan currently. uh, Warm restart is another area that we are not particularly considering for the phase one. So, okay, coming down to the scale, this is we have other documents that James, Christina, and all put together in the other section. So this is just a recap of what are the scaling that we are targeting to support. So number of VNets, ENIs are like 64 per card, and these routes, ACLs per ENI is captured here. The CAPM mappings is like 10 million, and total active connections that we are looking for is like 1 million in bidirectional. So these are the scaling numbers for reference here, so that way our design has to consider these kinds of big scaling numbers. So one of the things that before we go into the design considerations, so I put forth um, this section mainly uh, to capture that the regular SONiC design is slightly different from this Dash project because we are looking at the high performance, high scaling use cases. So the current SONiC is has to be like some restructuring or some redesign is required for handling such kinds of scales and performance. So that's why these design considerations are put, and this is very important for this is very critical for our design. So let's go over one by one, and I think we can spend some time um, parsing this. Yeah. So first of all, the implementation must support like single and bulk update of LPM and CM mapping table. So basically, like we are looking at 100K routes and 10 million mapping. So of course, programming it one by one is definitely time consuming. So we'll plan to support bulk update in all layers like GNMI, um, mm, the the SI layer, the occasion layer, at the SWSS layer. So all those sections we are targeting for bulk updates. Um, so mainly like in the startup, it is possible to have scaled configurations, right? Like during that appliance coming up, then we can have these kinds of scaled configurations applying um, like in very short period of time. So once the system is stable, we expect mapping updates like the CAPM mapping updates for a VNet to occur like 100 mappings per second, and in normal operation, route updates like routes are 100K per ENI, so this can happen like every 30 seconds. So these kinds of constant updates and should be expected, and the design should be able to handle that. Um, Now, another thing is like if an adding or a deletion of VM by the customer can have update to the ENI and routes in such bulk context, right? So when a new VM is created, these many routes, and if it is an associated to a new VNet, then you can expect to have a lot of mappings also created. So that's on the add and delete of VM. And the other key point is about the ACL operations, right? So the rules, adding and deleting per group for a stage, the expectation is to handle it atomically because we should not have a transient um, drop or forward cases, because if let's say the rules are applied one by one, there would be like some transient period where the packet forwarding or drop is not expected according to the expectations. Yeah. So so for a particular group, we plan to have the installation of that ACL rules to be handled atomically. Yeah. Any questions? I see Chris has raised his hand.
Yeah. Thanks, Prince. As far as scale, like these bulk updates and these large bulk updates, have you done any experiments, like even with a virtual side backend, to look at the performance of just SONiC by itself without even with respect to the physical device? Like
so on the as you know, like maybe once we come down, I'll explain how the current flow is and what we are trying to improve. So basically, there is a research ongoing with how much of DB updates can happen in one API call. I don't have the current numbers that's being worked upon. So we will be updating this HLD based on our findings. Yeah.
Yeah, I think it'd be good just to have a reality sanity check. Well, we can do 100,000 updates on this size of processor and this amount of memory, and it runs reasonably well, or it runs slow as a turtle and it can't possibly work this way, right? Good to have a early warning if there's something way out of bounds here.
Sure.
Thanks.
Okay, now coming down, the implementation must support also the ability to get all the ACL rules and the groups based on some group ID. So that's based on the schema definition. We can go over that. Okay, so the other thing. Okay, this is just for a reference. Like in the normal operations, mapping can churn often, and then followed by routes, and then least for ACLs, because ACLs is like customer driven. So if there is a change, then only it can get propagated, or a new set of ACLs will be applied. But otherwise, this is the order of churn that we expect. The next is like ENIs. So there's one point which we have to consider is during an ENI creation, like right, there will be like mappings associated, routes associated, ACLs. So we cannot have an ENI to be programmed in a partial way, right? So the intention here is to have the controller apply all the configurations of the ENI, and then later bring the ENI like administratively up. So it's like the port up and down kind of scenario. So the ENI, if it is down, the packets destined to this ENI shall be dropped. So once it is up, only the packet forwarding happens. So here, one thing to note is the order of operation, right? The configurations of mappings, oracles. So these are all controlled by the controller. Like SONiC will not be enforcing any order of operation. So it just honors the order that is set forth by controller, and then once the administrative state is set to up by controller, then SONiC will just enable the ENI. Yeah. Then here, like ENI and or VNet delete, we are expecting, or we are planning to support a mapping deletion of all mappings and routes in single API calls, instead of like again doing bulk updates or single mapping delete. If you say like delete map all, then we can internally go ahead and delete all the mappings associated to that. At this point, the add and delete APIs are idempotent according to the GNMI standard. However, our team is also analyzing what is our implementation. So for example, deleting an object, what idempotent here I refer is deleting an object that doesn't exist shall not return an error. So it will be just accepting the API and then returning success. This is as per the GNMI spec, so we will also be validating that, and if there are any other observations, I'll rephrase this. Yeah. During a delete operation, if there are dependencies, that's one case, right? Like if VNet is planned to be deleted and if mappings are still present, then the implementation shall return error and not perform any forced deletions or deleting the dependencies implicitly. Then during bulk operation, if any part or subset of API fails, the current implementation of GNMI shall return error for the entire API. So there will not be any partial updates happening for a single API call. Yeah. Then implementation must have flexible memory allocation for ENI and not reserve max scale during initial create. So this is some feedback from our internal discussion. So basically, the card or the plans, when we create an ENI, it should not pre-hand reserve like these 100K routes or such things, so that like for small VNIs, we may not scale up to that. So this is to allow some sort of oversubscription. Then finally, the implementation must not have silent failures for APIs. Like if an API is accepted by the from the controller, then and returning success, it is not expected to fail in the backend and have inconsistency between the controller and the SONiC implementation. So these are the main considerations that are considered for this design. So any questions or?
Yeah, I have a couple of questions, Prince. Thank you so much. I think this is good. When you say there shouldn't be any silent failures, right? But at the same point, you were saying that, okay, if you know, in the delete case, if I read it correctly or understood correctly, if you you should accept it and not really return an error, right? Even though something doesn't exist, right?
So that's what. So here it is not causing an inconsistency between the controller and the device, right? The controller has asked the SONiC implementation to delete something, which is anyways not present in the plan. So the point is, like here, what I meant is, if let's say a VNet is supposed to be created or deleted, and we accept the API, but the VNet still exists in the device, or the ENI still exists, that's not expected. So for example, same way with the add, like if the object already exists in the device, and if a controller is doing a duplicate add, that's fine still, right? Because the states are in sync between the two.
Sure.
Maybe I can rephrase if it is not clear.
Yeah, I think if you can rephrase that, idempotency, I think everybody understands. But if you try to do multiple ads, then like, okay, it just basically that were to be happen, right? But I think if you sometimes the deletion part is that you're trying to delete something and then it doesn't exist. Should we even return an error, right? So, and then if you're saying, you must not silently fail, then, essentially here you're silently failing, so to speak.
Okay, got it. So I think, yeah, maybe I can take that feedback and update this that it's orthogonal to
Sure.
idempotent. Yeah.
Sure. Thanks. Yeah. And the other question I have is, since these requirements or considerations are putting certain requirements of how the API is going to really look like, right? And what kind of APIs you're expecting, whether it's the northbound or the southbound, like SI or versus the GNMI. So that also, in my view, is also putting requirements on how we are going to define the behavior models, right? Since we are generating SI APIs using those behavior models, that essentially is an input to the behavior model. I think we should probably have a little mention of that one here, saying that, okay, these requirements essentially we're going to distill into how we're going to write the behavior models.
Yeah, Hanif, I'm really glad you brought that up. I was going to say something similar, especially with point 9 here in the design considerations. There's a certain amount of orchestration and sequencing here. Like, what it implies to me is you need to make a lot of table entries, and then at the very last step, open the floodgates. Enable it administratively. Is there even a -psi primitive for that at this point in time? Is everything going to be controllable through psi as listed here, or are there going to be some out of band or some other mechanism, which I think we want to avoid? And if we're just generating the psi from P4 tables automatically, is there an allowance for, do we need a table that's just like an administrative state table, or is there an attribute for administrative for an ENI that lets you do this effectively through the psi interface? It's kind of a question for Marion. Is everything here covered by the current psi auto generation?
We don't have admin state to actually drop packets if it's down, but we can add it. It's not really a problem.
Yeah. Do we have a consensus, or can people think about, do we want to make sure that everything listed here can be controlled through psi with the right semantics, and we want to avoid unmentioned interfaces or unspecified interfaces for doing this?
I agree that, I agree that wherever is required and necessary or applicable, I should say, for psi, we should definitely spell it out. Yeah.
I mean, I guess to put it bluntly, we want to avoid band-aids after the fact, right?
Right.
Secret APIs and special fixes, everything should just be spelled out in the APIs, and they all should be pretty upfront. Okay, thanks.
Yeah, especially when it comes to administrative up after setting up everything, right? You don't want any other side channel, options. Yeah.
Yeah, if it's not in psi, you can't do it. That would be another rule, right?
That's right.
Yeah.
Thank you very much for this.
Sure. I think, Marian, we can also work offline to define this if that helps. Yeah. Okay, so coming down, we have the packet flow. This is again explained in detail in other sections of this Dash repo. So I just put here for reference. Basically, in the outbound directions, we have the VM, the packet coming from the VM that goes through ACLs and then routing, then having the encapsulation and going to the network. So the outbound examples are given at the end, so we will go over that in this discussion. And then I have the inbound packet processing where the packet is coming from the network that goes to routing, then ACLs, and then doing an encapsulation and going to the VM. So this is mainly for reference. It's not very detailed in this document, but I'm sure like Christina has a good document elsewhere. So with this packet flow pipeline in mind, we're going to the modules design. So as most of you would know, like in SONiC, we have the config DB as well as the app DB. So in this design, we are planning to have the dash objects programmed to the app DB with the prefix dash. So this way, any regular configurations like the underlay configurations are all isolated from the dash. And we don't have to have some stale configurations like during config save, restore, etc. So that's the intention why we are not putting all these entries to the DB. So this is a new requirement to the JNMI because the current JNMI design has the configurations directly put to the config DB based on the Yang model, but we have put the requirement for JNMI to program the app DB if it is like dash. So that's the plan. With that, there are not much of config DB objects that are being changed for SONiC. So except for the device metadata that I have captured here in the requirement about appliance and DPU. So those are the only changes expected in the config DB. Coming to the app DB, so here is the object at a high level. So we have ENI and then we have VNet. So these are the tables that are associated to an ENI. Sorry, is there any question?
Yeah, Prince, I have a question.
Yeah, sure.
Yeah, so based on what you described earlier, where you're not going to put anything into the config DB, so is that correct? The expectation is if the DPU rebooted, then we'll basically have to reconnect to the controller and get a full config from the controller again.
Right.
Okay, got it.
Right.
Thanks.
You're right. So, but like I said, because it's in the app DB, we will in future we are planning to support the warm reboot of the card. Yeah. So in that warm boot, we will not expect the controller to reprogram everything, but in cold boot, yes.
Will there be any way to import or export a configuration based on like a text file representation, like a JSON file?
Not, at least not considered here, because if it is cold boot, it's like a fresh start of the device, right? So the reason why at least I haven't considered that is because we will plan to provide warm boot. If all the configurations has to be restored, then we can employ that model.
Yeah, it might facilitate testing at some point.
Okay.
That would be a lot more work, Prince, or?
Because it's, I think it will be more helpful for like some test purposes, but for config restoration, I don't think we can have that unless there is some hooks in the JNMI to load from a JSON and.
Oh, okay.
Yeah.
I was thinking more of something that would not necessarily be related to GNMI, but it would be a very simple mapping from the DB, the Redis DB.
Yeah. I think that we can, of course, that's supported. Like today, if you have a JSON file, I think maybe we'll go to that example. If that is part of a JSON file, you can just directly apply to the DB. Yes.
Okay, great. And you know, this is an ongoing discussion we've been having. I don't want to distract the meeting. We can let's have that meeting sometime.
Yes.
Smaller meeting. Thank you.
Sure.
Thanks, Prince.
Okay, so at a container level, here we see that ENI has these objects. The route table, ACL, and QoS associated to ENI, and VNet will have the mapping table. So that's just giving a high-level reference, and now we have that each definitions for each of these objects, like we have dash VNet, and then we have dash QoS. So it's the key is VNet name, and then you have all the associated attributes. Then you have the ENI, which has ENI as the key, and then associated attributes. I've tried to define all these, what these attributes are intended for, and also the good reference is the other document that is in the dash repo on the config model. So that will have some examples as well. Now,
I have a quick question on.
Yep.
So, in the ENI, you know, in what conditions an ENI is associated with multiple different VNets because you define that, okay, the list of VNets that the CNI is associated with.
Yes, that's
okay,
the peering scenario, right? So if you are if you have like VNet peering, you can say like this ENI has VNet associations to, let's say, VNet 1, VNet 2, VNet 3. So that means it's kind of a peering scenario.
Okay. So this is something that we are not tackling as part of VNet to VNet because it's just on the intra VNet right now, the use case we are doing. But once we do the VNet peering, then this would become probably more evident,
so
right?
So VNet peering is part of the phase 1 requirement. So it is considered here.
Okay.
Yeah.
Oh, no, I think I was just looking at those 7 different use cases in which there was VNet was separate in the VNet peering, and we thought we were only doing intra VNet part right now.
Okay, maybe I can correct here. VNet to VNet means like VNet and VNet peering. Yeah.
Okay. Okay.
Yeah. Okay. ENI, then yeah, we have the ACLs. Like ACLs are having like groups and rules. So.
Prince, is there a typo here? Because if I read the key for ACL, should that ENI MAC and stage as the key as opposed to state?
Oh, ENI MAC and stage as the key. Yeah, this is a typo. Yeah, okay. That's right. Yeah, it's not the state, of course. Yeah. So yeah, thanks. I'll to correct that.
Or I might basically go ahead and send you the PR, and you can correct
yeah,
it.
Sure. Please go ahead. Yeah. Okay. So ACL, we have like in and out ACLs associated to ENI, and then there could be like multiple stages. So that's why the stage is planned as a key, and then you have the group association for that, and each group will have a group ID and a GUID that the controller can reference to, and then the rules are associated to the groups. So here, how we ensure the atomic behavior is like, if let's say there is a new set of ACL rules to be programmed, then the controller can program a completely new set of ACL rules, and then in one shot commit that ACL group to an ENI. So that way the previous one gets replaced with the new one. So that's the intention with ACL, and the definitions are, or the definitions of attributes are here. So some of the key points here is like the ACL rule has protocol, source address, destination address. And let's say if you look at the protocols, it's a comma separated set of values. And if nothing is mentioned, it's like wildcard. So these are like optional fields, like if protocol has like no values specified, it means the rule should apply on all the different protocol types. Yeah. So capture that here. Yeah, and then we have the list of source IPs and destination IPs. Yeah. All right. So coming down to routing type, this is being referenced in the mapping and in the route table. So we have different routing types. It can be like direct, VNet, VNet direct, VNet encap. So I will explain those in detail in the upcoming sections. So we are not having the routing type private link, NSG, and service tunnels in the current phase. So we'll be more looking towards these 4 actions like direct, VNet, VNet direct, and VNet encap. And then you can have different actions. Actions can be map routing, direct, static encapsulation, and some of these are again part of the private link scenario. So we will not be considering that in phase 1. However, I'm putting it for completion. Yeah. Encap type can be VXLAN, GRE. So like based on the action type, the other fields need to be populated. So that's why some of these fields are like optional. But it means like in the Yang I have defined. So there is a Yang file also as a PR. So here the dependencies are clearly described, but however in the schema it is hard to define. So basically what it means is, let's say if the action type is VXLAN, then these two fields are mandatory. Or actually, yeah, so that's the point. But in general, these are like optional fields from an implementation perspective. Yeah. Okay, routing type. Appliance is just like giving the source IP of the appliance and also the VNIs that needs special treatment for setting the directions. Yeah. Coming down, these are the two main tables, like the route table that's associated to ENI, and then you have the mapping table that's associated to VNet. And these are the different attributes in the route table. And again, like some of the cases I have clearly defined here, like overlay SIP is needed if routing type is service tunnel. So we are not having the implementation for this in the phase 1. Yeah, and for each of the different routing type, these attributes will take its own meaning. So that's why these are defined over here. But let's go to some examples maybe that will clarify. Mapping table, I think this is the CAPA mapping table. So IP address is the CA, and then you have the PA address as underlay. There is also a routing type required in the mapping table, which we can which we can go over later. I think one question in the PR as a comment was why we have routing type in the mapping table. Yeah. Now on the module interaction, let me zoom. Yeah, so the plan is to have the controller using gRPC API, and then we'll have a GNMI container, basically that accepts all these get set calls, and will write to the DB, which will be the app DB based on the current design. And then we have the SWSs that subscribe to these app DB objects, and then we'll have a dash or kgen that writes to the syncd or the ASIC DB. So this is at a very high level how the API flow will happen. Yeah.
Friends, if there are failures during the programming, right, the SAI API's programming, we don't calculate that to the controller, right?
Right. So the thing, so I think that's a good point. Currently, from the backend, if the failures, how to propagate is something that that we need to find, like basically some sort of error state or the state DB objects that the controller can also do get operations to see what is the state of that object, like if it is programmed or not programmed. So we have today the some state object that reflects the final state, right? So similarly, something has to be done. Yeah, I think that is also some one thing to.
I think pins have introduced something that we can probably
right?
leverage. Exactly.
Yes.
So app state DB.
Yes.
And then you can actually utilize that particular area to really communicate the errors to the controller.
Right. I think those are being considered. So we just need to work with the GNMI team to how they can read from that the different tables to return back to the controller. Yeah.
Prince, it looks like there's an echo question from Jay Park in the chat window. Is there a special way to specify? Go ahead.
I'm not seeing the chat window, so
I've got it. I've got it. Yeah, it just says, Jay, do you want to ask your question if you're online?
Yeah, so I was just wondering if there's a special way to specify all port ranges versus and prefixes, or do we need to add like 0 to 65535 and 0.0.0.0/0 prefix to specify all address ranges and port ranges?
Okay. So I think I have defined that in the Yang, but let's take a look. Group. Yeah, I think I should give some good examples here. Yeah. But the intention is like here you can have the source port and destination port as list, and then you can specify the range as the pattern like here. Yeah, maybe I think I can put some examples here if that helps. Yeah.
Okay. Yeah, sounds good. I think it looks like we need to specify from like 0265535 if you want to add all port ranges, right?
Yes. Yes.
Okay.
Do you
sounds
want
good.
to do a PR against this, Jay, or do you just want to write it down, Prince?
This is a PR which we haven't merged it yet. I think there are lots of good feedback from Venkat and others. So I'll have to address all those before we can merge. Yeah.
Thanks.
So yeah, I think if you can put that as a comment in the PR, that would be good.
Sure.
Can you do that, Jay? Yeah,
I'll do.
thanks.
Yeah.
Just a quick comment there. I think your 2 to the 16th is wrong. It should be 65535.
Oh yeah. Yeah.
You are so
Yeah.
funny, John. You're very precise. Thank you.
It's a typo. Yeah.
Okay. I think I
Prince,
would have gotten it from some place. Let me check what was it defined there. Yeah.
one more question. You mentioned a little earlier talking about combinations of parameters that were hard, let's say restrictions in the Yang that are expressed in the SONiC DB schema. What's your expectation of the validation that we do at the SI interface? For example, if certain things are mutually exclusive or there's certain requirements that are expressed in must statements, do we need to implement that at the site boundary, or is the controller going to do that level of validation, or both?
I don't think that is at the SI layer required because that validation happens at the northbound.
Okay, it does mean that we're doing testing at the SI level, we could get the device into a state that doesn't make sense, right? If we programmed it,
Yeah.
for some reason. Okay.
Yeah.
Prince, the ref counting, etc. When you reference some of the objects that you are trying to program using the controller, and if that has dependencies on the local control plane, right? So that reference count check and the interdependency checks you're doing in the org agent, isn't it? Or
So
will that be handled?
Org agent has dependency, but at the DB layer also we can do some checks, right? Let's say if mappings are there associated to VNet, then it doesn't need to be on a reference count basis. If there is one existing, then we can return failure, right? Is it like at the org agent layer? Of course, there will be like reference counting in place, but at the GNMI layer, I don't think there will be reference counting, but it will just check if the objects are present.
Okay. Yeah.
Yeah. Okay, so we have touched upon this overall design. However, like
I'm sorry, can I ask a question about this picture? Just you know, for myself to make sure I understand and to recap. So the auto generation from the behavioral model, is it generating the SI API dash module, or just the interface, the library that the SI API dash module will use to interact with the SDK?
That's a question maybe Marian can answer better. Here we are using the SI API in this, based on this flow, it is the SI API that the org agent would be called. But on the auto generation part, Marian, can you help answer?
Yes, we're generating only the interface. That's it.
So the interface between that module in yellow, the SI API dash, and the ASIC SDK.
No, not between the SDK, the interface itself. The implementation is on vendor, so it does not know anything about the SDK.
Right. No, but the interface. So this API, the SI API dash, is the API which is actually between those two modules, the yellow one and the white one, the SI API dash and the ASIC SDK.
Yeah.
Or okay, so the mapping between the objects in the server and the SI API, is it implemented into that yellow module?
I don't really understand which object you initially were talking about.
So the controller is going to use the GNMI dash API, okay, to configure the device. The server will map the GNMI messages into object into the DB, into the Redis DB, right? So the effect of any call of the GNMI API is going to be some objects being created, deleted, or modified into the database. At this point, those objects need to be picked up by syncd and somehow translated into calls to the SI API that we have.
So which DB are you talking about, AppDB or ASICDB? Because there are two layers.
Right. I want to understand that because it's not clear to me. Is this what's running on the host CPU in a smart switch, or is this running on each and every DPU in the smart switch?
Each and every DPU has this SONiC stack subset shown here in this drawing.
Okay, so like in the web documentation, there's a diagram that says high level architecture that shows a GNMI container in multiple of these syncd containers. Is that just like some logical diagram that's spread across multiple DPU instances, or is that what's?
Yeah, I think, John, that is a different architecture itself, where we have like different syncd containers across DPU. So I think this we can just focus on the appliance and clarify on the flow, because that's a whole different design discussion.
So I understand, like on the appliance, this would be the diagram for each and every DPU.
Yeah.
And the smart switch, you think it's different, or you think that this also
exists? No, I think that's a design we can either have a syncd replicated, or we can have its own SONiC instance. But that doesn't change the flow, right? So.
Okay. All right.
Right.
Maybe it's not the right discussion for this meeting, but I would like to understand, like.
Yeah, I think smart switch, maybe Christina or Gerald can help answer, and we can have maybe a separate discussion for that.
Okay. Okay.
Because we have. Are we trying to say? Are we trying to ask the question on whether SONiC should run on every DPU in a SONiC?
No, Gerald. I mean, I totally understand that SONiC will run on every DPU, but like, I just don't know like where these containers run. Do they run on the host SONiC, the switch SONiC, or do they run on the DPU SONiC? That's my question. It's just like the split.
This is the conversation we have with Liwa and Gohan, where they can move around depending on the analysis, once we have something going, I think, Gerald.
I think it can work in both ways. The problem is we have no performance data to say definitively that this should move down to the DPU or it should stay up at the switch. I think the desire would be, for that piece, if it was on the switch, you'd have one instance. It might be easier to manage the device that way, but that's just a desire. We don't know if that scales, and we don't know if that would perform. And so that's kind of been left open until we do something. Like, we don't have any implementation to actually know whether it would perform or not. I worry it won't perform, but I'm open to, like, if it does perform and And,
Okay,
and it's fine, then I would have no problem with it, but we're not at that stage.
Okay, so, but as, you know, for us to make progress, like, we can at least assume for the appliance and at least the starting point of the smart switch is that this diagram exists on each and every DPU.
Yes, and that's mandatory for any appliance. I mean, they would all
Yes,
be
yes,
running
yes.
independently with the full set of containers.
Yes, okay, understood. Thank you.
Okay.
I'm sorry, I just want to go briefly back. Given that this is going to run in wherever, every DPU, the mapping between the high-level API and the objects that API generates in the DB and the SI API dash, is that mapping performed by the yellow process there called SI API dash?
No, I think this is the SI API definitions, like what the orc agent here will translate from the application DB object to the
Do you want to go to the
basic
next
DB
diagram?
objects.
Do you want to go to the next diagram?
Yeah.
Maybe I can step in and help a little bit. It's a little more detail, and I drew this diagram to try to help myself understand it, and Prince accepted it into the document. So Mario, what happens, the flow is the gRPC GNMI call gets made. The GNMI server makes an appdb entry. Then there's a subscription notification to the orc agent that then transforms those high-level appdbs into ASIC-DB or SI conceptual objects in the ASIC-DB. Then the SONiC stack, the syncd container, subscribes to those changes and propagates them and just basically makes calls almost transparently to the equivalent SI APIs. So if there's a table access, and that's all done in SONiC. It's not even, the vendors don't even need to write any code up to that point, right? Microsoft is kind of taking on the orchestration and the GNMI. So you really just have to handle everything from the C level call in the SI API down. And Marian did a really nice job in the behavioral model of writing Jinja templates, translate those SI calls into P4 runtime calls. It's kind of a neat thing. You can look at that as its inspiration.
Yes, but so if I understand correctly, the appdb is at the abstraction level of the GNMI. The ASIC-DB is at the abstraction level of the SI API. The translation is performed by the orc agent.
Yes.
Okay, great. Thank you very much for clarifying. But at this point, I have a follow-up question, which is, as we generate the SI API, shouldn't we also auto-generate the schema for the ASIC-DB? Because the schema depends on our behavioral model.
No, the schema is auto-defined. Like basically, if you are making an orc agent call to based on the SI API, it will be internally taken care of. If you're talking about the schema for ASIC-DB, we don't have to explicitly define that.
The thing is that it is sometimes the case that that more than one primitive in behavioral model, more than one primitive in SI will be mapped to one entry in the schema. So it's not exactly one-to-one, it may be many-to-one. And that's why it is done manually, because it's what we have in the appdb is closer to how the user will see things. And then we may do some more complex translations and also handle dependencies and so on before we get to SI representations.
Yeah, no, but that's okay. But is ASIC-DB already the SI representation, or is there a further translation based on what Chris said? ASIC-DB is basically
ASIC-DB is SI representation, yeah, but ASIC-DB does not have schema. ASIC-DB is fully serialized based on SI API. So it's kind of like what you mean. It is auto-generated, but it's already in place. You don't need to do any work for that.
Okay. Got it. I mean, I understand what you're saying. I didn't understand how it works, but I will look into it. But this clarifies. Thank you very much, Mark.
Yeah, I want to check in, Prince. We've got 8 minutes left. Do you think we'll need to go into a second session, or?
No, I think I can try to cover the remaining section, and if we need, we can plan. So.
Okay.
Hey, sorry, like I just have one question. Like so, since like so in the above diagram, right? There is 2 DBs, ASIC and AppDB. So for every object, for example, like route, we will have two instances, right? In one. In each of the DB. So yeah, when the full scale config is loaded, like for example, I saw like 100K routes per ENI, so it's like 6.4 million routes. So like we will be having like 13 million routes in this DB. So like have we considered like the memory usage when scale is low in terms of
absolutely. So we have the memory section down. So we're working on like what will be the scaled memory usage with that many routes. We are working on that. So I'll come to that memory section and what we are planning to do. I'll touch upon that. Yeah. So so in the interest of time, let's go to the SONiC next section, the SONiC host container. So not all containers will be enabled in the appliance scenario. So we'll have like some TeamD and DHCP, etc. containers that will be disabled. So basically, this section captures what all will be active. And here,
Hey,
the
Prince,
ORCID.
Prince, I have a question on the container. I noticed you have telemetry mark as enable. That is in SONiC, that is currently hosting the GNMI server, but then you also have the dash GNMI container earlier. So is that an extension to the telemetry container, or is that a new container?
So that's the new design going on with the GNMI, right? Whether they plan to have both in the same container or they will have it in. If they have it in 2 different containers, that will be a design that that's part of the GNMI.
Okay, so you're saying either you consolidate, then that would be part of telemetry container. If it's a separate telemetry container, will be turned off in that case for Dash. Did I get that right?
Telemetry is still required for Dash. So whether it is part of GNMI or whether it is part of separate, both will be available.
Okay, but mainly handle the GMI aspect, but for telemetry purpose versus the Dash configuration aspect.
Yes, that's right.
Got it. Thank you.
Okay. So on the overlay dash org-agent, we have it briefly touched above. Basically, there is a dash org that will do the translation from AppDB to SAI, and then there is this a regular underlay for the DP as well, like creating the port. Some traps like BGP has to be enabled. So these are the existing underlay SAI APIs that we will be using in the DPU world as well. So that's this. It's a small section of underlay routing. And here is the memory footprint. Like here is where, to the previous comment, we will be adding more data here based on the scalability. So currently, with all base Dockers and no configuration, it's 1.3 gig, and we have the upper limit like probably 5 or 6 gig, which we are trying to see how much would be the usage with the scaled configuration. That this section will be updated based on that findings.
Yeah, and also Prince, the container list that you had it above. Probably needs to synchronize with this list as well, because this has fewer containers than the one that you're asking for as a yes column from the previous list, right? So.
Oh, did I miss some containers?
I don't know. There was a GNMI container I didn't see listed.
Because that is still in development, so I don't have the container yet.
Okay.
Yeah.
Okay. So then once you have it, then you'll have to probably.
I think the only missing one would be the GNMI, because that's.
Prince, do we need any SNMP operations for Dash? Why do we need SNMP container?
So SNMP get is still a monitoring part. in our deployments, Venkat. So they do still do like, sometimes the PA reachability of the appliance, such like get or the loopback reachability. Those things are still handled through SNMP.
Okay.
Yeah. Okay, and the CLI section here, like I discussed before, like we have the show and the clear commands. So I put here. So in case like for some purpose, if we have to clear all the configurations on the appliance, then we can leverage these commands. Now coming to the example configuration. So here is what I talked about, like the lookup, how it can happen. So let's say we create a VNet and then an ENI, and it can say like this ENI has the VNet1 association. So so you create a VNet, you create a VNI, and then specify the routing type. Let's say map routing. Okay, this is a list of action, but let's consider only one case here. And then we have the other routing type as VNet direct, and then we have the VNet encap. So let's assume there are three different routing type defined. We can ignore this private link for now. And you have a routing table of like for different prefixes and the action type. So here, 10, 1, 0, 16, 24. I'm defining these different tables based on the previous definition. So I have like three different route tables, or like four different route tables for different prefixes. And then I have a mapping table for different CA addresses. So with these configurations, let's take an example for a packet destined to 10.1.1.1. So if so like I said, this is the outbound direction. If I quickly go back here on the outbound direction, you have the ACLs routing. So this is the flow. So I don't have the ACL example, but in the routing, let's come back here. It hits for the 10.1.0.16 entry because that's the most preferred matching. And then it says that action is VNet. So
why would that be the case? Shouldn't that /24 be the most?
10.1. Yeah. Sorry. Okay, I think I need to. No. So 10.1.1 falls here, right? Because this one is actually incorrect. It is 10.1.10/24. I'll fix.
Okay.
That.
Okay.
Yeah.
So that otherwise, this would have been basically
correct.
Yeah. Okay.
Yeah. So I'll fix that. So this should be like. No. Actually, it is correct. Like 10.1.1.1 will fall into this only, right? 10.1.1.1 because it won't fall here.
Yeah, that's correct, Prince. Yeah.
That's correct. Yeah. Sorry, I think it is correct. Okay. So it goes to VNet, and then it says that the map routing. So it goes to the mapping table for VNet1, and in the VNet1 mapping table, where is that? Here we have the mapping table, and it will find for 10.1.1.1 as the prefix. What is the next action? So think about it. It first look into the map routing table. Then the routing table says that go to the mapping table for the next action, and it goes to the mapping table. And in the mapping table, it says the routing type is next is VNet encapsulation. So and then you have the PA address from here. Now going to the VNet encap. Here is the routing action, routing type VNet encap. And for that, the action is static encap and use VXLAN. So this is the action. So final action will be a VXLAN encap. And what is the VNI and PA address? That's derived from the mapping table and the VNet. So that is the intention of this section, like how the different encapsulation can happen. Now this is one more thing. I think 3 and 4 are straightforward. So one more quick explanation for this scenario, 10.1.0.1. It goes to the routing table here, 10.1.0.1. It says VNet1, and I have defined in the schema what this overlay IP means. So when it goes to VNet1, it's similar to the previous one, but it has an attribute 10.0.0.6. So which means even if the CA or the destination is 10.1.0.1, your lookup to the VNet1 should happen based on this overlay IP. So you are so basically here with overlay IP specified. So now the lookup will go to the VNet1. So VNet1, but it will not look for, in the previous case, it was looking based on the packet's destination IP. But in this case, because the routing table has specified a specific overlay IP, it goes to this VNet1 for this destination. Even though it is 10.1.0.1, it goes to 10.0.0.6. And then it says that, OK, it is VNet encap as the action, which is same as before, but use underlay IP as to this IPv6. So see the difference. So that's the intention with that lookup.
No, I don't understand how it decides that the mapping table for 10.0.0.6 should be the hit.
Because it has been defined in the routing table.
Yeah, so 10.0.0.6 in the routing table. And then, so then what you're basically saying is that in the mapping table's key is actually a VNet and the overlay IP, because this prefix, then it has to basically, so this prefix is essentially saying that this is actually an overlay IP prefix. For somebody else, it's a different prefix, has a different definition versus the one, this one, right?
For somebody else, meaning?
No, meaning that for the previous example.
So previous example, if in the routing, if there is no overlay IP specified, then it will use the packets or the destination IP. Yeah. So my point is like these are like complex routing and lookup scenarios, but these are the different modes of operations or different. Yeah.
So plus, I think what Prince, I know in the interest of time, I wasn't basically trying to look for this one, but in the second example, when you say the hit is .24/24, is this a typo here? Because there is no lookup entry which has .24/24 in the routing table.
I think this is 10.1.0. I think this is definitely a typo, because this one should be 10.1.0.0/24.
Okay, so. Yeah, I was trying to look for this one and I can't. But then when you have an overlay IP, I wasn't sure how you hit the overlay IP to really decide that you're going to enter into a different mapping table in order to really do the right action. So,
I wonder if we should have a Q&A session. This is a lot of content, and I wonder if we should give people a week to ingest it and then take like 45 minutes for Q&A next week. Would that be okay, Prince?
Yeah, I'm fine. I think, I think we can also add to the PR if there are more questions.
Yeah, absolutely. Absolutely. Yeah, so if the community could take the action item to add to the PR, then we could take the action to deliver a Q&A based on that. Would that work for everybody? I can't see everyone's head, so yes, yeah.
Yeah, I think everybody's going to have questions. I even have some questions.
Yeah, this is a lot of content, and we'll have to coordinate with Prince, or if you have someone else from the SONiC team, if you're busy. Yeah, but maybe we should put that on the agenda for next week.
Yep. Okay.
Okay, great. Are we through the content for today, Prince, or should we keep going?
Yes. No, I'm done.
This is wonderful. This is just huge, Prince. It's so great. I think there's going to be a lot of questions, but this is a massive amount of work. Thank you so much. What do you think, Gerald?
No, I think it's great, and it definitely deserves another meeting. There's going to be lots of questions. Like I said, I even have some questions, but so it should be the next meeting.
Yeah. Okay.
Yeah,
so
it is great work. It's people have been asking for this for a long time, and this is a good start.
Yeah. Everybody, get your questions into the PR contact Prince, and we'll try and cover this next week. And Bud, I know you had a question. I'll try and get to it offline for you. I'm going to stop the recording and post it to the YouTube channel. And it's 10:07, so I'm late for another call, of course. And I hope you all have a good day and a good week. Thank you, everyone.
Thanks.
And thank you, Prince.
Thank you all.
Thank you.
Thanks, Prince.
Okay. Bye-bye.